7.4 is on what's called the remainder and factor theorems. Okay, so these, it's not like super important that you remember exactly what the theorem is, but we're going to use the factor theorem like all the time. I'm just not going to refer to it as the factor theorem. So it says when working with polynomials, we will be using synthetic division a lot. So do you guys all remember synthetic division? Feel pretty good with that? So it says use synthetic division to divide p of x equals 5x cubed. So we have 5x cubed minus 13x squared plus 10x minus 8 by x minus 2. So when I'm dividing by x minus 2, do you guys remember what I put in the backwards L? It's 2. Yeah, it's like if you had set it equal to 0 and solved. Okay, so we always drop the first term. A lot of you guys messed that up on the final. You like put a 1 there, or I don't know what you did. I think you dropped the term here and then added and got 10. Okay, so we're not doing that. We're just dropping it all the way to the other side of the line. So we drop it and we get 5. Now, if you remember, every time we go diagonally, we're multiplying. Anytime we go up and down, we're adding. So go ahead and try it without looking up here and see if you can do it. See if you remember it. All right, so you get 5, negative 3, 4, and then a remainder of 0. Did you guys all get that? Okay, so it says, well, what is p of 2? So if I went through and I went back to my original problem and I plugged in 2, I would have 5 times 2 cubed minus 13 times 2 squared plus 10 times 2 minus 8. And it's not very fun to compute because I have 8 times 5, right? 2 cubed is 8. 8 times 5 is 40 minus 4 times 13. Some of you guys may not know that off the top of your head. You could double it and double again. You get negative 52 plus 20 minus 8. And then we have to combine all these numbers. So we're like, okay, I got 40 plus 20 is 60. Negative 52 and negative 8 makes negative 60, so 60 plus negative 60 becomes 0, right? Okay. In many ways, that way was harder. So there's a little shortcut. So if you do synthetic division, it gives you the value of like f of 5, f of 2, f of 7, if you put 5, 2, or 7 in the backwards cell. Okay, so this right here is the same as p of 2. Isn't that weird? So the remainder is the same as the original, or as if you had plugged it in. So that's what it says. So it says if the polynomial function p of x equals, or is divided by x minus a, then the remainder is the same as p of a. Okay, so in other words, the remainder will be the same as it would have been if you had just plugged a into the function. Sometimes it's much easier to just plug a into the function. Sometimes it's much easier to use synthetic division. So you can kind of choose your battles. So it says, no, if the remainder is 0, remember, that's good. That means that it factored. So just like with regular numbers, Michael, you with me? So with regular numbers, if I get a remainder of 0, that means that it factored evenly, right? So that's what goes further. So we have the remainder theorem, and now we have the factor theorem. So the factor theorem says if x minus a is a factor, then f of a equals 0, or the remainder equals 0. Oops, remainder. Okay, so this one says the polynomial is p of x equals 5x cubed plus 32x squared minus 11x plus 75. So it says find the quotient and remainder when we divide by x plus 7. So we're going to do negative 7 in the backwards L. So go ahead and do your synthetic division. All right, and we're going to do negative 7 times 5 is negative 35. We add straight down, we get negative 3. Negative 7 times negative 3 is 21. We add straight down, we get 10. Negative 7 times 10 is negative 7. We add straight down, we get 5. Okay, so that didn't take very long. So what that's telling us is that p of negative 7 should be 5. That's the remainder theorem. That whatever your remainder is the same as if you would have plugged the number in. So the remainder theorem doesn't seem very crucial, right? We could have just plugged the number in. But part B says, well, go ahead and find p of negative 7 by plugging in. And that's where it gets a little bit difficult, because if I'm finding p of negative 7, I'm going to have 5 times negative 7 cubed. Do we know negative 7 cubed? Plus 32 times negative 7 squared minus 11 times negative 7. Was it plus 75? Yeah, plus 75. And this is a really hard problem to do, especially if you don't have a calculator. So if you didn't have a calculator and I asked this on the test, you guys would be like, what? Does it just mean, Mrs. Cox? I think you could do it. Like, you could do lots of scratch work off to the side, but you would all be cursing me. You'd be like, why did Mrs. Cox just ask me this on this test? So negative 7 cubed is negative 343 plus 32 times 49 plus 77 plus 75. And then you'd have to do 5 times negative 343. Do you see where this is going? Pain, isn't it? We don't want to do this. So I'm just going to say that this all works out to be 5. And you can check on your calculator. Did anybody check on the calculator? You get 5, exactly. Okay, so in many ways, synthetic division can be much, much easier than plugging in. Yes. You get it? All right, but that's not like the whole point of learning synthetic division in this chapter. Okay, so we're using synthetic division all the time, but we are not going to necessarily use it for the remainder theorem. Okay, here's how we're going to use it. So we're going to take our polynomial, and we are going to decide if things factor evenly. Because if they factor, what's that? So loud out there. If it factors evenly, then that means that it's an x-intercept. Okay, because we said that if we had a remainder of 0, then that was the same as like p of 7 or whatever we had. Well, if that means, if we have like p of negative 7 equals 0, that means on our graph at negative 7, we're crossing the x-axis. So we're putting it all together. Okay? So we're using it to find x-intercepts. That's the whole point of this with our chapter, which will help us graph. Okay, so it says use synthetic division to decide which numbers in this list must be zeros. Okay, so what we're going to do is we're going to do negative 1, and we're going to plug in. So we have 1, negative 2, negative 5, and 6. And we're going to do synthetic division. So I drop the 1. Negative 1 times 1 is negative 1. Add straight down, I get negative 3. Negative 1 times negative 3 is 3. Add straight down, I get negative 2. Negative 1 times negative 2 is 2. Add straight down, I get 8. So is this one a 0? No. So this is not a 0. Maybe I should say negative 1 is not a 0. Because we want a remainder of 0. That's the whole point. Okay, so let's say we try negative 2. So I have negative 2 times 1 is negative 2. Add straight down, I get negative 4. Negative 2 times negative 4 is 8. Add straight down, I get 3. Negative 2 times 3 is negative 6. Add straight down, I get 0. Are we good? So negative 2 is a 0. So what that means is if I was doing a rough sketch at negative 2, I would have an x-intercept. So you can have more than one 0. So we do 3. So how about this side of the room? You guys do 3. The other side of the room, you guys do 1. You're doing 3 because you already started it. It doesn't take very long, actually. So 3 is a 0. What about 1? 1 is also 0. So we have 3, and we have 1. Okay, and that's actually the maximum number of zeros that we can have, because this function was an x cubed. And when you have an x cubed function, the maximum number of x-intercepts it can have are 3.
Does that always correspond with the
Yep. And we know that they don't have multiplicity then because, like we said, the maximum number of answers we can have is 3. So none of them are going to have multiplicity then because we have the answer of 3, the answer of 1, and the answer of negative 2. So if I was trying to do a rough sketch, so quickly tell me, what is the y-intercept? Do we know y-intercept? Yeah, y-intercept equals 6 because I plug in 0 for x. And the end behavior, we know x cubed starts at the bottom, does a little squiggle, goes up top. So this is what this would look like. It would go up, it would hit the y-intercept, it would come back down. Whoops, I missed it. I did something weird. Oops, I'm messing up. I don't know how to get rid of that. We're just going to delete it. All right, so I could go back past, and then I would go up. Does that make sense? So that's what the graph would look like. Did you guys get it? All right, so now there is a little bit of an easier way. So once you get one of the zeros, so what was the first zero that we got? -2. What if we had written it in its factored form? So if I had written it, do you guys remember P of x equals D of x times Q of x plus R of x? Do you remember all that? So if I wrote this as x plus 2, right, that's what the -2 represents, the divisor x plus 2. And then I wrote the quotient, which was x squared minus 4x plus 3. What do you think you could do with the x squared minus 4x plus 3? Yeah, you factor it. So we're trying to find where it's equal to 0. Well, we have the x plus 2, and then we would factor the next one into x minus 3 and x minus 1, which gives you these other two zeros. Does that make sense? So you don't have to keep doing synthetic division all the time. Usually if you do it once or twice, then you have something that you can factor. Okay? All right, so let's go the other way. So it says find a polynomial of degree 3 with zeros of -1, 1, and 3. So we did this before your final exam last semester. So do you guys remember when it says you have certain zeros, how we set up our problem? No one. It has been a long time with J-term. Yeah, so Gloria's saying if you have a 0 of -1, it's going to be x plus 1. If you have a 0 of 1, it's going to be x minus 1 as a factor. And if you have a 0 of 3, it's going to be x minus 3. So you can write P of x or F of x, whatever you want to do. And then we just simplify it. We multiply it all out. So Eric, what's x plus 1 times x minus 1? Do you know that right away? X squared minus 1. Yep, so we have x squared minus 1 times x minus 3. And then we FOIL out the rest of it. So we're going to have x cubed. X squared times -3 is -3x squared. -1 times x is -1x plus 3. And that's our polynomial. So you can write -1x or just -x. It doesn't matter. Okay, is that the only polynomial with those zeros? No, you could have any like coefficient out front. So you could have any number kind of right here that you're multiplying it at the very end. Like maybe I say with the leading coefficient of 5, then I would multiply my entire result by 5, so I'd have 5x cubed minus 15x squared minus 5x plus 15. Make sense? All right, so that's what this one says. So find a polynomial with leading coefficient of 3, degree 3, and with zeros of x minus 2, so I'm going to do x plus 2, x minus 5, and x minus 2. And our leading coefficient was 3, so we're just going to sneak it in on there. So this is where you can be smarter than the problem. You don't want to like multiply x plus 2 times x minus 5 first, because then you get a trinomial, and then you have to take a trinomial times binomial. So what's the easiest thing to multiply first? Yeah, if you multiply these two first, right, those are going to create the x squared minus 4, which is just a binomial. So that will be a little bit easier to do. All right, and then we go from there. So now we have x squared minus 4 times x minus 5. So I'm going to have x cubed minus 5x squared minus 4x plus 20. And then last but not least, we multiply the 3n because it said we needed a leading coefficient of 3. So we have 3x cubed minus 15x squared minus 12x plus 60. Make sense? Yeah. So you guys can have lots of strange things for zeros. So we did things last semester where we had like zeros of -1/2. Do you guys remember those? So if I had a 0 of -1/2, then you would start it out by saying, oh, well, I could have x plus 1/2. But we don't really like when it's fractions. So do you guys remember how we adjusted that? Yeah, just multiply by 2. So instead, 2x plus 1 also has a 0 of -1/2, right? If I set it equal to 0 and solved, its answer would be -1/2. So you might have fractions as well. And as the next couple show, you might also have i's. So we did not do i's. Well, we might have done one. I think we did square roots in the last semester. So it says find the polynomial with real coefficients that have a 0 of -2 plus 5i. So it says question, if you have the answer of -2 plus 5i, what other answer must you have? -2 minus 5i. You need to have the conjugate. So if you have this one, you also have -2 minus 5i. Okay, and that directly comes from the quadratic formula from, you know, negative b plus or minus, right? The square root of b squared minus 4ac. So the plus or minus will give you that second answer. So this one is a little bit tricky, so pay really close attention to this, okay? So if I'm going to have a 0, remember how I was always setting it up as x minus each 0, x minus each 0, and so on? Okay, when you have like -2 plus 5i, that two-term thing, a binomial, you need to put parentheses around your 0, okay? Because we want to make sure we distribute that negative in. So we're going to write it as x minus parentheses -2 plus 5i. And then x minus parentheses -2 minus 5i. And we're going to multiply these together to get our polynomial. So it's a little cluttery, too many parentheses, so we're going to clear that inside parentheses by distributing our negative into each thing, okay? So we're going to distribute the negative, and we're going to get x plus 2 minus 5i times x plus 2 plus 5i. The original negative, like the minus? What are you saying? The minus 5i? This negative?
Yeah.
Because it's always like x minus, like if you had a 0 of -3, remember it's x minus a -3, it was x plus 3. If you had a 0 of 2, it was x minus 2. Right? It's always the opposite of what you had. Like if I told you you had zeros of 5, -3, and 2, you would write x minus 5, x plus 3, x minus a negative. That's what we're doing. All right, now we have to simplify. You ready for this? All right, here's what we're going to do. We're taking the x times everything in the first. It's not as bad as it looks. You can do this. Power through. X times x is x squared. X times 2 is 2x. X times 5i is 5ix. Now what do? Take the 2 times everything, right? So I'm going to do plus 2 times x is 2x. 2 times 2 is 4. 2 times 5i is 10i. And last but not least, take the -5i times everything. So we're going to have -5i times x is -5ix. -5i times 2 is -10i. And -5i times 5i is -25i squared. And if you do it correctly, you will know you did it correctly because all the things that have I will go away. It will simplify down to the just nice little polynomial. Okay, so let's look through. We have x squared plus 2x plus 5ix. Do we have a minus 5ix somewhere? Yep, right there. So our 5ix and our minus 5ix are gone. All right, but then we have plus 10i. Do we have a minus 10i? Yep. But then it looks like we still have an I squared. We have -25i squared. But what is I squared? -1, right? So when we combine, we have x squared. We had 2x and 2x make 4x. We have 4. And what do we get when we do -25 times -1? This is all plus 25, right? So we're going to have 4 plus 25, so we're going to get plus 29. That is our polynomial. So it simplifies down to a nice little neat thing. All right, now some of you guys might like this trick that I'm going to show you. Some of you may not like it. So if you want to write this in your additional notes, if you don't have room, you can do it. So let's say we, so this is kind of a shortcut. So I never did this little shortcut in school. I never knew about it. And then I started teaching at IU, and they used this weird book, really strange book. And it had this method in there. And I was like, oh, that's brilliant. I would never have thought to do that. So I'm going to show you a shortcut. And if you guys feel like you want to do the shortcut, you can. So it starts out the same way. So it starts out as x minus the 0, x minus the 0. So our zeros were -2 plus 5i and negative 2 minus 5i, right? So we started out and we're like, okay, I got x minus a 0 in parentheses, negative 2 plus 5i, and x minus a 0 in parentheses, negative 2 minus 5i. And the second step's the same. We distribute the negative, so I get x plus 2 minus 5i times x plus 2 plus 5i. Okay, so here's the weird thing. If I had w plus 5 times w minus 5, do you guys all know without foiling out what that would be? Yeah, w squared minus 25, right? Do you guys all see that? All you do is you square the first item, right? You multiply the first items together. You multiply the last items together. And why do we know we can avoid the middle, like the outer and inner terms? Because we know they'll cancel out. This is set up the same way. This is like x plus 2 and x plus 2. That's like our w. So we have it set up as something minus 5i and that same something plus 5i. Okay, so when we have that, something minus 5i times something plus 5i, what we can write it as is x plus 2 squared minus 25i squared. You guys get that? And then we just have to FOIL out our x plus 2 squared. So that's going to be x squared plus 4x plus 4. And then our minus 25i squared, remember I squared was negative 1, so we get plus 25. So we're down to x squared plus 4x plus 29. Done. So if you like that method, you can do it. If you don't, it doesn't take very long. I feel like people complain for longer than it takes to actually do the problem with these. They're like, ugh, I don't want to FOIL this all out. I want to multiply this x by everything and the 2 by everything. And then, like, after they're done complaining, I'm like, you could have been done. Like, you just spent, like, 2 minutes saying, oh, I don't want to do this. So just do it. It doesn't take long. It's not a hard concept. All right, so it says, if you're given that 2 is a 0 of x cubed plus 7x squared plus 2x minus 40, can you find the other two zeros? Okay, so if we know that's a 0, Eric, head up. Then we put 2 in the backward cell. And we have 1, 7, 2, and negative 40. Because when it says 2 is a 0, that means x minus 2 was the factor, right? Some people get confused and put a negative 2 there. All right, so drop the 1. 2 times 1 is 2. Add straight down, we get 9. 2 times 9 is 18. Add straight down, I get 20. 2 times 20 is 40. Add straight down, I get 0. You should get 0 because it said 2 is a 0. So then its factored form was the x minus 2 times this quotient, 1, 9, 20. So 1, 9, 20, what do I write? Plus 9x plus 20, right? X squared plus 9x plus 20. And we're trying to find the zeros. So Eric, you're saying what? X plus 4 and x plus 5. Do you guys see? So we fully factored it. Factored it all the way down. So what are our 3 solutions? 2, negative 4, and 5, or negative 5. So our other 2 zeros are negative 4 and negative 5. Okay, that's going to be what we're doing constantly throughout the chapter. Okay, so section 7.6 is, you find one of the zeros, you break it down, you find all the rest of the zeros. Can we handle that? All right, so let's stop there.